Hi everybody! I love pie. How about you? I love getting the ingredients together. I love blending them and watching them mix. I love heating up the oven to cook, and I love to watch it bake and transform into something else. And the result of it is delicious energy that lets my body run for another day. Well, guess what? Today we're going to talk about the Krebs cycle pie. It bakes off in the mitochondria. It's used as a second step for cellular respiration. It produces energy for our body, and it feeds electron transport and produces lots and lots of ATP. So guess what? It recycles itself. What? A never-ending supply of pie? Go figure. To start this off, we have to preheat the oven. It's called glycolysis. That's what takes one glucose molecule and turns it into two pyruvate molecules. The pyruvate oxidizes to acetyl-CoA, and that's the ingredient we need to start this pie off. Let's look at each piece of the pie. Acetyl-CoA mixes with oxaloacetate and citrate synthase to make citrate. The second piece mixes the citrate with iconitase to form isocitrate. Piece 3 is dependent on mixing the isocitrate with isocitrate dehydrogenase to make alpha-glutarate forming NADH and releasing carbon dioxide. Piece 4 is alpha-ketoglutarate using an alpha-ketoglutarate dehydrogenase forming NADH and releasing carbon dioxide while making succinyl-CoA. Piece 5 takes succinyl-CoA and mixes it with succinyl-CoA synthetase, making succinate. And guess what? It releases one ATP molecule. Piece 6 uses the succinate and mixes it in another enzyme SOS, releasing FADH2 and forming fumarate. When mixed with fumarase, fumarate becomes malate. And the last piece is the best because the malate mixes with the malate dehydrogenase, releasing NADH2, forming oxaloacetate. And yes, from the first piece, it starts all over again. One cycle makes 3 NADHs, 1 FADH2s, 2 CO2s, carbon dioxides, and it releases 1 ATP. Remember, it takes 2 cycles to use 1 molecule of glucose. 2 pies? Wow, that's a lot of energy.